lecture gonna be special because in this lecture we're gonna discuss about the most important topic of thermochemistry, that is entropy and enthalpy. Before starting these two topics, we have to look at two different terms that are widely used in this field. First is state of system and state of function. To understand both of the terms, first take an example of a person. Just suppose that this is person who covers the distance from point A to point B. Now here, if you're going to have look at the distance that he covers from point A to point B. Now if we're going to find out that how many steps did he take, like he took 3 or 4 steps, what were his temperature at that time, what was his intention at that time, why he was going there, this all is known as state of system. That basically means this guy here is a system and we are talking about the state, his chemical reactions, that includes things like intentionally that cannot be physically be seen. The best example can be physical state. After that, when he started the distance covered from here to here, just suppose that when he was standing here, what was his pressure on it, what was the volume on him, and when he covers the distance, or we can say that when he from the point A to point B covers the distance, so at the final point, what was his temperature then, and what was his feelings then. This is known as the state of function. Now you can identify both differentiations by the terms state of system and state of function. Now if you're gonna have look at the ending part, system and then function, you can easily determine. System basically means the inner condition of a object. Here we don't talk about the initial and final position, we talk about the things that happen while covering the distance. But here in the state of function, you talk about the outer system of the object. Here you're going to talk only about the things that happen to a body from point A to point B. You don't talk about the things that happen between the covering of the distance. Back to the topic. Our topic was entropy and enthalpy. So let's have a look at entropy and enthalpy. There's a minute difference between entropy and enthalpy. If you're going to have a look at the definition of entropy, so entropy is basically the measure of the randomness of a object. It is a thermodynamic quantity which measures the randomness or disorder of the molecule system. We cannot calculate the absolute value of the entropy, but we can calculate only the change in entropy. Because at the initial stage, just suppose that this is a person, you cannot calculate that what his thing is like that, like how many particles in this person is, how many randomness of the particle there is, but you can check whether just place a pressure beaker here, and after that, just suppose in the time period of 3 seconds, I have given the person time period of 3 seconds and I have increased the pressure here. So what happened to the person here? You can calculate the average of the entropy, but cannot talk about the absolute entropy. Now entropy is measured by del S. It is denoted by del S and its formula is Q upon T. Here its unit is joule per Kelvin. That is also known as 1 entropy unit. Keep that in mind. This is the 1 entropy unit and this is also known as calorie per Kelvin. That is not the 1 entropy unit. 1 entropy unit is joule per Kelvin. After that, if we talk about the enthalpy, the definition of the enthalpy is that the total heat content of a system, or we can say that heat content of system, sum of internal heat and the product of pressure and volume. If you're going to have a look at its formula, it is, you can also not calculate its absolute enthalpy of any object, you can only take the average. So it is denoted by del H, that is equal to the sum of the total average of the internal energy plus the average of pressure and volume. Its formula is somehow like Kelvin joule per mole. Now here, both of these, entropy and enthalpy, are state of function, because in here I said that we don't talk about the internal condition, we only talk about the average of both. We cannot take the absolute value of the entropy and we cannot take the absolute value of enthalpy too. So here we take the average. That probably means the initial point and then the final point. We subtract the initial point from the final point and we put in the formula that is needed, but we cannot calculate the absolute value. So this is how it works, and thank you so much for watching this video. I hope that everything is clear to you all.